Alright, so let's continue with question number 15. So if you remember, a body of mass 5 kg moves along a straight line under the action of a variable force. If it is a variable force, we'll have to draw the graph from x is equal to 0 to x is equal to 4. So see, roughly if I draw a graph, let's say along the x-axis we plot the displacement and along the y-axis we plot the force. Now from x is equal to 0, that is from here, to x is equal to 4, let's say up till here, the force acts in the direction of the displacement and increases linearly. That means this is how the graph will look like. The force is constantly increasing. And up to what value is it increasing? Up to 20. Right? Then from x, this part, from x is equal to 4 meter to 6 meter, the motion of the body reverses. It means what? It means that the force is still in the same direction, that is 20 Newton, but the body is moving backward. Okay, like if the force is in this direction, okay, the body is moving in the opposite direction. Is it fine? So if the force is in this direction and the body is moving in this direction, what will be the work done here? Positive or negative? Negative, because they are in the opposite direction, right? But the graph is the problem. Even though the motion reverses, in the book they have given the displacement to be still 6 only. Okay, that's one problem that I have not able to understand why they have given it like this. But for now, I think let's just do what the book is saying. All right. So that means I'll draw it with a green marker. From here to here, the body is reversed. That means the motion of the body is reversed. That means the work done is negative, because the force and the motion is in the opposite direction. Okay? Yes? Okay. Now the next part. Okay. From 6 to 10 meter, from 6 to 10 meter, the force becomes negative. So again, here also they have not mentioned negative means how much. So we are assuming that the force is still minus 20. Okay, the force becomes negative, acting opposite to the original direction of the motion. Calculate the net work done. That means the body is moving in this direction only. So is it a variable force? No. So something like this. Okay, here the force was increasing. Here the force and the displacement is in the opposite direction. And here the force is negative. Is it right? So how do we calculate the work done here by the variable force?
Can you explain again?
Which part?
X is equal to 6 and then x is equal to 10 and then force is going negative.
Yeah. See, the body is now moving from 6 meter to 10 meter, right? That means the displacement is in this direction. That's fine. And the displacement is being done by a negative force. So now the displacement, the graph will not be here anymore. Suddenly the force has become negative. So directly from here, the force will now become negative. And the negative force is pushing it by 4 meters. You got it? Okay. So the work done we'll calculate in 3 parts. This one, and this one. So only for this, it's a variable force. So let's calculate for this. Number 15. So work done from 0 to 4 meter. From 0 to 4 meter. Let's say it is W1 will be equal to area of triangle. Let's mark these points A, B, C. So area of triangle A, B, C. So we know that area of triangle is half into base. Base is 4 into height. Height is 20. So cancel, 2 become 40 joules. Now this part, be careful. This part will calculate the work done now. So work done from 4 meter to 6 meter will be, let's say it's W2. So W2 will be force into displacement. Since the force is not variable, we can directly use force into displacement, and we know that it's going to be negative. So it will be minus, force is 20, displacement is 4 to 6, so 2. So it will become minus 40 joules. And lastly, work done from 6 meter to 10 meter. W3 will be equal to, again, it's not a variable force, so F into S. So write it till here. I just want to check your understanding.
But for the second word, why don't we use the area?
We can use the area, but that's an overkill for this, right? Since the force is not a variable, we can just use force into displacement. If you think about it, we are using the area only. Like for this, we have to find this area. And what shape is this? What shape is this, Ananya? Rectangle. So rectangle is what? Length into breadth. So the length is the displacement and breadth is the force F. So we're using that only. You got? Okay. Now you tell me for this one, work done for 3, will it be positive or negative, the work done? Yes?
Negative.
Negative. Why negative?
Because the force is in negative.
Very good. Because the force is in the opposite direction to the original force, but the motion is in the same direction. If you see, it's written here, the force becomes negative acting opposite to the original direction of motion, right? So the force is negative, so it will be F into S, so with the negative sign. So it will be minus F will be 20 only, and the displacement will be 6 to 10, so 4, so minus 80 joules. We have to calculate the net work, so therefore net work done will be equal to the sum of all, so W1 plus W2 plus W3, so it will be minus 40 or plus 40 plus 40 minus 40 minus 80, so it will be minus 80 joules. Okay, see, this question is very interesting. All right, and try to understand this question really nicely, because there are a lot of questions similar to this. Question number 2, find the gravitational potential energy of 1 kg mass kept at a height of 5 meter above the ground. So that's simple. All right, straightforward question. Nafi, what's given? Mass is 1 kg and height 5 meter. What do we have to find?
Gravitational potential energy.
What is the formula of gravitational potential energy?
Mg.
Okay, very good. mgh. So we can substitute. M is 1, G they have already mentioned, take 10, and H is 5 meter. Sorry. So 10 into 5 will be 50. SI unit of energy is joules, since everything is in SI unit. The second part is the interesting part. See, it says calculate its kinetic energy when it falls and hits the ground. Okay, so what will be its kinetic energy when it falls and it just hits the ground? So for example, something like this. Okay, it's falling and it hits the ground. So what will be its kinetic energy now? Kinetic energy will be equal to the potential energy, right? Why? Due to conservation of mechanical energy, or yeah, we can write mechanical energy. So kinetic energy will also be 50 joules. Okay, let's see question number 5. Question number 5, what does it say? A boy weighing 50 kgf. So given weight means force, force is 50 kg F, climbs up from the first floor at a height of 3 meter. That means there's a building and he's at the first floor at a height of 3 meter above the ground to the third floor, which is at a height of 9 meters above the ground. What will be the increase in his gravitational potential energy? So how do you think we'll find the increase in gravitational potential energy? He was here, so he had certain amount of gravitational potential. From here, he went up to more height. So obviously his gravitational potential energy will increase. By how much? How do you think we'll find?
So we have to take those height by h1, h2.
Okay, we can take the height as h1. h1 will be, let's say, 3 meter, and the greater height h2 will be 9 meter. Okay. Then how do you find the increase in potential energy? See, we can use a formula that is mg h2 minus h1. Basically, it says find the potential energy here and subtract the potential energy here. That will be the increase, right? Just imagine that his potential energy at this height was 5. Okay, let's just say. And here the potential energy was 2. So what was the increase? What was the increase in potential energy? 3. So how did you get 3? What happened? How did you get 3? 5 minus 2. So basically this potential energy minus this. So that is what we did here. Like basically it's mgh2 minus mgh1. Then you can take mg common and we get h2 minus h1. Then after that just substitute. So mass will be 50 kg. G is 10. Then H2 is 9 minus 3. Then 5 6 are 30. 30 and then 00. So everything is in SI unit, so joules. Because force is 50 kgf. See, 50 kgf means the force applied by a mass of 50 kg. Okay, that's the meaning of kgf.
Force equals to mg, so can we directly just put 50?
We can, but then it will not be in SI unit. Okay, then the unit of force will be in kgf. So the answer will be kgf meter. We don't want that. You can imagine it like this also, that kgf, we're converting it to Newton by multiplying it with G. Okay, if you don't understand this, you can also remember this. You can convert kgf to Newton by just multiplying it with the value of G. Got it? Are these questions easy, or should I go to the tough ones, or how should I go? Are you guys understanding? That's fine, no? Okay, let me just go a little bit tough then. These kind of questions are also asked, okay, a lot. Question number 9. Question number 9. If the speed of a car is halved, how does its kinetic energy change? So first of all, you tell me, if a car's speed is halved, will its kinetic energy increase or decrease? That's very obvious, because kinetic energy is directly proportional to the velocity. So if the velocity will decrease, kinetic energy also will decrease. But how much do you think it will become? Will it be halved as well, or it'll be further decreased? Okay, let's see. Let's say that the velocity was initially v. Okay, and let's say that now the velocity is halved, so it becomes v by 2. Therefore, k1 upon k2, where k1 was the old kinetic energy, k2 is the new kinetic energy, will be what? Simple, half mv square upon half m v by 2 whole thing square. Now you can simply cancel. So half gone, m gone. Then I can open the bracket. So I get v square divided by, here I'll get v square divided by 4. Then 4 will go up, v square we can cut. So we get 4. That means k1 upon k2 will be equal to 4. So from here, if you find k2, you'll get k2 is equal to k1 upon 4. Do you get till here or not? First tell me. Did you get till here, the derivation? Okay. So that means what? If the original kinetic energy is k1, the new kinetic energy will be divided by 4. So that means it will reduce 4 times. Therefore, we can just write new kinetic energy will be 1/4 of the original kinetic energy. So this is the derivation, but in the exam you'll have to remember. So how do you remember? I'll give you a trick. Okay, see, if the velocity is decreased by half, that means you are dividing it by 2. So if it is 2, then your kinetic energy will be reduced by 2 square, that is 1/4. Okay, imagine that it was decreased by, let's say it was decreased by 1/3. Okay, your velocity. What do you think your kinetic energy will be decreased by?
1 by 9.
1 by 9. Why 1 by 9? Because it is nothing but 3 square. Similarly, one more time. If let's say V is decreased by 1/5, your kinetic energy will decrease by 1 by 25. Okay, simple. What if the question is changed? What if the velocity is increased by, let's say, 2 times, that is doubled? So if your velocity is doubled, what do you think your kinetic energy, will it increase or decrease? First of all, it will increase. It will increase by how much? It will not be 2 times. It will be again the same thing, 4 times. Okay, very easy. 1 by 3, so just square it, you get 1 by 9. 1 by 5, so you square it, you get 1 by 25. 2, you square it, you get 4 times. Okay, similarly, velocity is increased by, let's say, 10 times, then your kinetic energy will increase by 100 times square. You got it? Why is it so? Because in the formula, the velocity has a power of 2 square. That works for everything, okay? We will see this a lot of times when we do electricity also, we'll see something similar concepts. Okay, so let's put whatever you have understood to a test. All right, question number 15. A body of mass 10 kg is moving with a velocity of 20 meters per second. If the mass of the body is doubled, so that means we are increasing the mass, and the velocity is halved. That means we're decreasing the velocity. Find the initial kinetic energy and the final kinetic energy. All right. So let's do the initial kinetic energy. That's easy. DJ, what's given?
So the mass, which is 10 kg, and the velocity, which is 20 meters per second.
Velocity is 20 meters per second. What do we have to find? The kinetic energy, right? So initial kinetic energy. What is the formula of kinetic energy? Do you remember?
Mass and speed per second.
That's the formula of momentum. Just now we used it. Yes? Very good. Half mv square. So half mass is given to be 10, v is given to be 20 squared. We can cancel this and this. We get 5. 20 square is 400. 4 5s are 20. So 2000 joules. Now look at for the second part. The second part is interesting. Here what we are doing, we're doubling the mass. Okay. Now if you increase the mass, what should happen to the kinetic energy? It should.
Oh, sorry. It will increase.
It should increase, right? Because it's in the numerator. So if the mass increases, the kinetic energy should increase. Okay. But what we are doing to the velocity? Velocity is being halved. That means velocity we're decreasing. Now if you decrease the velocity, what will happen to kinetic energy?
Decrease.
It'll decrease. That means mass, it's trying to increase the kinetic energy, but velocity is trying to decrease it. My question is, what do you think will happen finally? Will the kinetic energy actually increase or will it decrease?
Decrease.
Decrease. Why decrease?
Because velocity is less and mass is more.
Okay.
So it decrease.
So why will it decrease?
Because when
Don't say the same line.
so because the velocity is less, that's why.
But why does velocity have more control over the kinetic energy than the mass? Anyone? Very good. Because here the velocity is being squared. So kinetic energy is directly proportional to the square of velocity. Okay. So if the variable has a higher power, it will have a higher control over the kinetic energy. You got it? We'll see this. Number 2. According to the question, new mass, let's call it M1. So how much will be the new mass? It's being doubled, right? So it'll be 20 kg. Then new velocity, V1 will be, it's being halved, so good, 10 meters per second. So please find the new kinetic energy.
So 1000 joules.
You got it? So half mv squared. So half into 20 into 10 square. Okay. So we can see that it actually decreases. All right. Grisha, question number 17, what's given? Mass is equal to 60 kg. My mistake. Yes. And momentum, yeah, momentum is P. Momentum is how much? 3000 kg meters per second. We have to calculate its kinetic energy. Okay. Now, do you remember the formula of kinetic energy with respect to momentum? Half mv square. Good. But see, half mv square, when we say, we need mass as well as velocity. Do we have the velocity? No. So what you can do if you don't remember the formula, you first find the velocity from the formula of momentum. Momentum, what is the formula? Mass into velocity. So from here you find the velocity, then put the velocity here and you'll get the answer. Okay. But if you remember the formula directly, it's easier. It's p square by 2m. Okay. Kinetic energy is p square by 2m. So we can substitute. So we get 3000 into 3000 divided by 2 into m. M is 60. So we can cancel 0, 0, 6, 5s are 30, then 2, 25. So 25 3s are 75,000 joules. Okay. The next part, you also have to find the speed of the body. So eventually you have to find velocity.
See,
You got the velocity? Which formula did you use?
that momentum is equal to mv
Okay.
in the starting only.
In the starting only? Okay. So momentum is 3000, mass is 60, and velocity we have to find. So velocity will be 0, 0 cancel, 6 5s are 50, no? 50 meters per second. Okay. Let's see question number 20. What does it say? A bullet of mass 50 gram is moving with a velocity of 500 meters per second. A bullet of mass 50 gram is moving with a velocity of 500 meters per second. It penetrates 10 centimeter into a still target and comes to rest. So bullet moving hits a target. The moment it hits a target, obviously it will experience a force, right?
I thought bullet train. Oh, yes.
After throwing that bullet,
I saw that bullet train, sir.
Why did you do this for bullet train? Okay, Raghav. Yes. Okay. So bullet, yes. So it penetrated inside the still target and it came to rest. Obviously, the target will offer some kind of resistance, right? And it will try to stop the bullet from moving. So it stopped, but before stopping, it penetrated 20 centimeter inside.
So 10, so 10.
Oh, sorry. 10 centimeter. Okay. Calculate the average retarding force. So how much force did it apply in order to stop the bullet? All right. It's easy only. Number A.
What about you?
So first we'll do A. Kinetic energy. Kinetic energy I think you can do. Kinetic energy is half mv square. So half mass is 50 upon 1000 into 500 into 500. Then we can cancel 1, 2, 3. 1, 2, 3. Then we can cut this and this. We get 25. Then 5 5s are 25. 25 into 25 will be 6250 joules. Now let's see. The average retarding force offered by the target. Now this one, try to understand. The bullet had some kinetic energy, right? It was moving and from here to here, the bullet was stopped, right? You have to find out how much force was applied during the process. So do you remember any theorem that can help us to find the force? There's a particular theorem. When it reaches here, its kinetic energy will be how much? 6250. Do you agree? When it reaches here, what will be its kinetic energy? 0. So did its kinetic energy change or not? Yes. So if you remember, we did a theorem that is known as work energy theorem. And according to it, work done by a force is equal to change in kinetic energy, right? Work done by a force is equal to change in the kinetic energy. So work done is what? We know that it's force into displacement, and change in kinetic energy is half m v square minus u square. So force is what we have to find, the retarding force. Displacement is, since it penetrated 10 centimeter inside, that will be the displacement. So 10 upon 100, converting it to meter. Then half mass is 50 divided by 1000. Final velocity is 0. Initial velocity is 500. Please solve this, get the value of F. Yes. Thank you. Wow. Don't tell me that's the answer. Such a high force. Yeah.
So, but in book it's positive.
Yes, we'll talk about it. Right. So see, this enormous amount of force is needed in order to stop the bullet. All right. That is something that our body generally cannot produce. So it penetrates right through and gets out. No? Okay. So you got this. This is the amount of force. But you look at the question. Here it is saying retarding force. Retarding force means the force is against the motion, right? So retarding force already means the force is going to be negative. So when you write the answer, you don't have to mention the negative sign. When you write retarding, it already means that the force is against the motion. So retarding force will be without the sign, that is 65200 Newton, 62,500 Newton. Didn't get? Okay. A spring is kept. You forgot the word kept. I mean, you missed the word kept. A spring is kept compressed by a small trolley of mass 0.5 kg lying on a smooth horizontal surface as shown in the adjacent figure. So something like this. There's a trolley, there's a spring, and it has been held into a place by compressing the spring. When the trolley is released, right, or when the spring is released, it is found to move with a velocity of 2 meters per second. So this is the trolley, this is the spring, right? When the spring is released, the spring will be relaxed and the trolley moves with a velocity of 2 meters per second. What potential energy did the spring possess? See, it's asking what is the potential energy of the spring, right? Now, what kind of potential energy will it have, the spring? First, you tell me that. Huh? There are two types of potential energy. Elastic potential energy and gravitational, no? Adhasa? So, what kind of potential energy will it possess? Elastic potential energy. But for your syllabus, we don't have any formula only for elastic potential energy. Right? So, how do you think we can find the elastic potential energy? What's the workaround?
So we use a formula of elastic potential energy.
Yeah, very good. But we don't have it in the syllabus, Zishan.
And we cannot get it by our one.
Like, before if we know the formula.
It's not in the syllabus. And there are many values that are not given, okay, like the spring constant and all, even if we knew the formula. So there is no way to use the formula even if you knew the formula. What is the workaround? Yes, good. Yeah. See, we know that the trolley is moving with a certain velocity. That means it will have kinetic energy. Do you agree?
Yes.
Kinetic energy. And the kinetic energy will come from where?
The spring.
From the spring, from the potential energy of the spring. Right. So that means the elastic potential energy of the spring got converted to kinetic energy. Right. So we'll find the kinetic energy. So please find the kinetic energy.
So also that processing what potential energy rate it might have. Understand.
Fair question. Fair question. I'll explain. So what will be its kinetic energy? 1 joule. Raghav, this is where you, okay. See, this kinetic energy that the trolley has, this kinetic energy came from where?
So from the elastic potential.
Exactly. What, Raghav? You are asking, you are only answering. So it came from elastic potential, right? So that doesn't that mean that this kinetic energy is equal to the elastic potential energy? Yeah. You got no? Okay. What am I supposed to write? Huh?
To fire a gun.
You have fired a gun. Air gun.
ICSE.
Actual gun. With actual bullets. Where? Why?
So it was really good.
You have also fired.
Say penetrated human with guns. Yes, sir. So then Raghu was next to him.
Raghav is?
Was next to him.
So, but it was not required.
What? Which gun?
So I don't know. It's a very good gun.
Very good.
Huh?
Someone was taking me for him was going to the stuff.
0.22.
So, for him was going to for me was infrared.
What rifle?
No, I forgot that. The one to the army use. Then the army shoots strike.
AK-47? No.
Oh, AK-47. Say you can't shoot AK-47. It's can't shoot
Ah.
because of the recoil. But sir,
This is the first thing that you have said that I found interesting in so many months. You never say interesting stuff. I stop listening when your story starts with "Sir, my teacher said."
So if you get retarding force which is negative,
Huh.
then that
Just a force in the same direction. Yes. You guys are asking nonsense question that tells me how tired you guys are. Extra class? No. No, you guys have extra class, so I understand. But you guys, why retired?
extra cricket. No, sir.
For next week, physics said it should be.
Yes, sir. Tomorrow and Friday. Then we have to go to Sir Vikas competition.
So Friday at least only one class. What is the point of whispering when I can hear you clearly? Tell me. When do we whisper? When we want that others should not listen, no? But I can listen to you clearly what you are saying. Then why do just shout? That I don't know.